Okay, so at this point we need to take out, which is kind of like counterintuitive because we kind of just put it in, but x to the 2/3 and y to the 1/3. Which leaves us with x to the 2/3 plus y to the 2/3 over 3x squared y to the 2/3.
Now the 2/3 is x 2/3.
Yeah. And then subtract the exponents from the bottom. So that would be 3x to the 4/3. Yes. Yep. Y to the 1/3. And then x to the 2/3 plus y to the 2/3 on top. Oh, and we can leave it there.
Oh.
There we go. Okay. Wasn't as bad as I thought. You can supposedly take it farther, but we're leaving it right there.
It took up almost a whole page.
Yeah. Is there a lot in here to do that?
A little bit. You can.
I feel like it's kind of not going to be repeated.
So if I would have made it any smaller, I
Is
would
that too much?
It might get a little cold, but that's okay. We'll just turn it back if it gets cold.
Oh.
I'm warm at the moment, so. Okay. We're gonna do another one of those that is the first and second derivative. Hopefully one that's a little easier than that one. Y squared plus 2y is equal to 2x plus 1.
Oh, there's no fraction.
Well, yeah, there's no quotient rule in this one, so that's nice.
Oh, because like the first one started out with like x to the 2/3.
Now, that doesn't mean the second derivative won't, but
Yeah, but at least the first one won't.
Oh, yeah.
Josh was like, what?
I forgot that's what we were doing.
The second change.
All right, so first derivative would be
2y. Y
Y
prime. Plus 2y prime. Equals 2.
now what?
What's the
I get
promising?
the-
Oh, you gotta get y prime.
Oh, just
separated. So this
factor-
would be.
factor out a y prime.
I guess we did.
Well, because the y primes are already in
It's literally what you do.
I guess you can do that too. What else you gonna do?
So that gives me 2y plus 2 is equal to 2. I can divide by that. So 2 divided by 2y plus 2. Now what?
Can we like cancel out the 2's or?
Yeah, so since there's a 2 in every piece, I could like pull the 2 out. So this is they're all gonna reduce, and over here I'm left with a 1. And I'm left obviously with a 1 on top. So this will be 1 over y plus 1 is y prime.
Yes, you can do that.
Now,
But we can only do that because it's in every piece.
right,
So if it was a 2y plus 1, we wouldn't have been able to do that.
right.
Okay.
Now, I'm going to take the second derivative, but I'm going to make your life easier and not make you do a quotient rule. How might I do that?
You multiply by y plus 1.
By the y.
No.
Y plus 1 raised to the negative 1.
Yes. I'm going to rewrite this as y plus 1 raised to the negative 1. So now, instead of a quotient rule, I have a
Chain rule.
chain rule. which is a little easier to deal with.
Yeah, very much.
Product.
So, second derivative is equal to
Wait,
a 1, -1,
Negative one.
in parentheses y plus 1
to the negative
to the -2 times
One.
y prime.
yes, y prime.
Uh,
So we did the derivative of the outside times the derivative of the inside, which is y prime. Now what?
2. You gotta plug in the y prime.
Now again, I would use this form because it's going to make things a little easier. So this is -1 times y plus 1 to the -2 times y plus 1 to the -1. When I multiply, I do what with my exponents?
You
Add them. So that means this is going to be -1 times y plus 1 to the -3. And so then to finish it out, I would do -1 over y plus 1 to the third.
I mean, that was way easier than the other one.
See, we start out with the hard one and then we go to the easier one.
So that we're not gonna do all the easy ones.
All right, find dy dx. You're probably like, isn't that what we've been doing?
Well, I'm scared.
The whole
since
time?
It sounds too easy.
Is that not what we've been doing?
No, it is. 32. Y is equal to x to the -3/5.
Okay. So you want to
Can we
take the
just put
derivative. So you want to move. So the derivative of that would be -3/5 x raised to the -8/5.
Yes,
That's cute.
that's it.
Oh. Okay. That's fine then.
But
The only other thing you could do is move the x to the bottom to make it like -3 over 5x to the 8/5.
Yeah.
But the book leaves it like this.
Well, I'll
So,
leave it.
I'll
leave it.
40. Y is equal to 3 times 2x to the -1/2 plus 1 to the -1/3.
Okay,
Josh is ready.
I'm ready.
So
I
you
haven't
want to
even
take the
written it yet.
Hey,
Hold
I'm
up.
yeah. Okay.
Whoa, whoa, whoa.
Sorry.
Calm down.
Okay,
Okay. There's a chain rule though,
come back.
right? So
Yes.
Yes.
It is.
y prime equals -1. And then you know the inside. To the -4/3
Okay.
times is it -x? Wait, yeah.
Mm-hmm.
Yeah, -x to the -3/2.
Yep. And then the only thing we can really do at this point is do the negative times the negative, and I'm going to put the x out front. But negative and negative is going to become positive, so this will just be x to the -3/2 times 2x to the -1/2 plus 1 to the -4/3. And we're done.
Like
Like
problem.
done.
Yeah, like I'm gonna give you problems to do now. Somewhere when I can find them.
Right.
1, 7, 9, 13, 17, 30. Nope, not that. That's 30. I was like, wait a second. 31, 35, and 41.
7, 6, 7, wait. 17,
Oh wait, I need to hold on. I need to add one on here because you need one of those finding the second derivative problems. 27, 31, 35, and 41. There.
I hear the British coming out.
Nathan is the British. Huh? What y'all saying? I'm not British.
Oh goody, the next section's inverse trig functions.
No.
Wow.
Yay.
Get them prayers.